I will talk about Starlink measurements, what we have done in last 2 years. Okay. So why we are interested on Starlink? So 6G will most probably include non-terrestrial network element, and it's very important in remote and rural areas where the mobile network operators are not providing enough capacity. In northern Finland, Sweden, Norway, and other parts of the world. In Canada, it's very often used in remote villages. Almost every house has Starlink receiver. And we also want to know how it works, in which situation it works well, and so on. And that's why we are doing these measurements. And in 6G, in 5G, the NTN was a latecomer, so the signal is not optimized for satellite usage. So maybe in 6G they could do, or we could do something better and propose optimized waveform for satellite usage. So it's important to know how Starlink is built. Information is not very well available, but you can get some information by reading various documents and websites, because these parameters help you to understand the link budgets and so on, what is needed. And for example, if we use these Starlink parameters and calculate the link budgets for the Starlink receiver, we can then better understand how the direct UE access link budgets are, where the antenna gains are much smaller. What is the potential capacity for direct user access? And here we have this information, what we have found so far from the system. So the orbit height is something like 550 kilometers, 600 kilometers. They are using different frequencies. So Ku band, so it's about 10 gigahertz downlink and 14 gigahertz uplink, and then Ka band, which is 2 times higher, about 18 downlink and 30 gigahertz uplink. The problem is that then in the Starlink receiver, you don't know which band it is using, so you have to guess what is happening there. Then the waveform is of course proprietary waveform, like always in satellites. Maybe NTN, new radio waveform, when they appear, then we know what the signal is, but not in the Starlink case. But we know something, so subcarrier spacing is 200, so it's OFDM signal, 240 kilohertz subcarrier spacing, so that it can tolerate very large Doppler shifts. There are 1024 subcarriers, so that the total bandwidth is something like 240 megahertz. But for me, this sounds like this is this 5G new radio signals with the largest subcarrier spacing. So they have not been very innovative. Okay, maybe the innovation part there is then how the data is put in the subcarriers and how the control data is done and so on. Modulation in Ku band downlink, it's QPSK, and uplink, where the transmit power is less, is PPSK. And Ka band, they have these two plus then 8 PSK and 16 APSK, which are often used in satellite communication. And for the power, we see that we saw IERP values that are 32 dB watts per whole bandwidth. So it's over 1000 watts what they are transmitting, very high powers. And then the total bandwidth reserved for the Starlink, it's 8 times this 250 megahertz. So there could be 8 different channels in one satellite. The satellite Starlink system, what we have is shown in this figure. This is the receiver antenna. So it's about 57 times 51 centimeter antenna array. It's phased antenna array which tracks the satellites. In addition to this antenna, there is power source and Wi-Fi router. So you get the Starlink network by this Wi-Fi router. Then they have a different kind of service plans, and one is for fixed position, which is the cheapest one. We have this roam so that we can move to different places, and then there are some others. Now if you take this antenna there and its dimensions and the wavelength, then you can estimate that there are something like 1000 antenna elements, or there could be 1000 antenna elements in this array. So 30 dB array gain in this system. But I don't know they have these elements 0 dB I gain or 10 dB I gain, or what they have. And is this full antenna table used for 10 gigahertz band, or only half of it, or how it's done? It's open to me. Then with the system there is this Starlink app. So you upload it into your phone, and you can see different kind of statistics using that app. And then you can run also speed test provided by the Starlink using that app, and so on. And then the start of the system is automatic. You switch the power on and it starts operate. But when you shut it down, you have to use this app to switch it off. And our goals are to check how well this Starlink is working in rural and remote areas in a bit different conditions. I will show the figures later. So what I mean by this. And we try to see if the data rate is enough for various applications, and what are the problems with the systems, and probably with the other satellite systems then too. And then we want to somehow publish these results so that the public will see that how they can use this Starlink system. Measurements, when we started, we didn't know much about the Starlink systems. So one surprise was that even though there are several thousand satellites, there are very few in the north. You can see it in these figures that there are a lot of satellites in over Central Europe, but only 2 or 3 over Finland, Sweden, and Norway. Still, we have connectivity here, but if we would have thousands of users, then I think the capacity would be limited. But so far, users are very few. We didn't have idea how fast it connects, and based on the test what we have done in different places, if you have very good visibility to the sky, it's just few minutes, so quite fasting. If you are in bad place, then it could be over 10 minutes, and usually we observe that if it's more than 15 minutes, then it's better to stop and find a better place. It will not connect. But then if you are at the same place and restart the system, then then the connection is very fast, just few minutes or even less. Yeah. Then our purpose was to measure Starlink in East Finland, and then we had a big surprise that it's not working there. So if you go very close to the Russian border, it does not work because they have cut the service in Russia, and some beams cover both Finland and Sweden, Russia, and those beams are then shut down, and we cannot use the Starlink in the Finland. I'm not sure if the situation has changed, so have they redirected the beams so that it will work closer to the Russian border right now? Where we did measurements, these first measurements were done here in the bottom circle there, which is east part of Finland, so Puolanka and Suomussalmi area. And then second measurements were done in northeast east part, this Inari and Sevettijärvi area. And lately, few months ago, in Pöyrisjärvi wilderness area with the reindeer herders. So in different parts of Finland. So this shows the few places where we put the antenna. So we went to these forest roads and put the antenna there, and we put it in the open places and little forested areas like in these figures. So there are trees between the antenna and space, but still it works very well. So no problems. But if you put a building or hill, then it does not work. And I guess that if the forest is much more dense than these, like spruce trees and so on, then it does not work, or at least so well. And here are some results from the Starlink app. So there is this, it shows you Starlink speed and Wi-Fi speeds. So you can see it's over 100 megabits already last year. I think in best we had nearly 200 megabits per second in some places. We of course did also run some internet speed tests. This red line, so red arrow shows the pair, and this shows that it's matching quite well. The Starlink, what Starlink claims and what the speed test tells you. Then in Inari area where we were in winter time, so the speed was there even a bit higher. It was few months later than these first measurements, so maybe they had improved service rates. And then in this Pöyrisjärvi area, it's really wilderness. There is no electricity grid or nothing. We use these six-wheel drivers to go there. We had to be very careful how to transport this antenna so that it does not break in these very bumpy roads, but it survived both ways, so that's good. And here in this is reindeer herders cottage where we were testing it with the diesel generator, and this cottage is in the slope. So this leftmost figure with the vehicle, that is in the middle of that slope. So where I took the picture, the slope continues, and that caused us some problems. So first the antenna was very close to the cottage. There was quite good visibility to sky, but still when the correct direction of the antenna was then behind the cottage, so that it blocked it totally, so it didn't connect at all. Then I removed it by something like 10 meters and it started working and gave us some results. And then later on we put it in the top of the slope and it provided something like 50 megabits more data rate. So the place selection has big impact on the data rates. You have to know how to use, and maybe this is then part of the things what you have to tell to public, so where to place the antenna so that it works the best. And the app has now new features like this obstruction map you can see on the right. So there is these red dots are where it sees some problems, and actually these were these trees behind the antenna in this leftmost figure. But you need lots of time to collect this information. I think this obstruction map was done after 5 hours of usage. Then with this new version of the app, you can do ping test there, and you can see that over 99% of tests were successful. Latency in our measurements was something like 74 milliseconds. Largest latency was over 100 milliseconds. So not bad, not bad. And what we plan to do next? So far we have used the Starlink own test statistics, but it's company owned statistics, so we are not. Can we be 100 rely on it 100% or not? And our aim is to confirm these results by using other tools. So we have Cosium tool, what we plan to use, and iPerf tool also. They both do similar kind of measurements, but this Cosium is more capable. And we want to do same test what they are showing there. So throughput, the number and duration of connection breaks, latency, and so on. I think this ends my presentation. Are there any questions?
Thanks, Harry. I'm looking in the Q&A. There are no questions. I have one very quick question. We don't have much time now, but did you mentioned about the capacity as well in the beginning, that may become a factor later on. Can you already say something about? I mean, you were pretty much alone, perhaps, using this in these regions, right?
Yeah.
Do you expect the performance to decrease once more people are going to use it?
Yeah. Okay. But I'm not sure where the limit is, but
no.
But
it's nothing you could measure.
Given the data rate, and if they have 8 channels. 8 channels, so it's a lot of capacity. 8 times 200 megabits, so it's over gigabits of capacity.
Yeah. Okay.
So
good. And one more question now.
Users, yes.
One other question in the Q&A. Did you test it under mobility conditions, or is it mostly static?
It was static, so we don't have this mobile version, so you cannot drive with this antenna. We plan to have it, but it's not yet in our hands. Yeah.
Okay. Thanks a lot, Harry. We are moving on in the agenda. We have two more talks. The next talk is by